Hi folks, Mr. Long here with another screencast on factoring. We're going to do what's called factoring by grouping. You've been factoring by grouping for years, we just haven't called it that, okay? And we're going to use the grid method to factor, and I'll explain how the trinomial factoring that we've been doing in the last little while is really just factoring by grouping. So here's x squared plus 6x plus 8. I'm pretty sure we know that two numbers multiply to 8 add to 6. Those numbers are 2 and 4. Now, so if we did it by grouping, here's how we would achieve this. So what I would do is go x squared plus 4x plus 2x plus 8. Okay, x squared plus 4x plus 2x plus 8. And then we would put them in the box, right? X squared plus 4x, 2x plus 8. So you can see the first two terms go in the first row, the second two terms go in the second row. And by the way, it does not matter if you have 2x here and 4x here. Okay, so again, this is called factoring by grouping. So what I'm going to do now is finish this out, and then I'm going to come back and talk about a ratio. Okay, so for this one here, again, I common factor x squared and 4x. X is the common factor. And then I common factor 2x and 8. And that would be plus 2. Then I divide. X squared divided by x is x. And 4x divided by x is plus 4. Giving us the factored form of x plus 2, x plus 4. But what you're going to notice is this. Let's look specifically at the ratios. So, and I'm going to do the ratios up here. So the first coefficient is a 1. The second coefficient is a 4. Okay, so let's look at that ratio and now compare it to the last two terms. 2x and 8. Well, that's 2 to 8. Are those equivalent ratios? Is 1 to 4 the same as 2 to 8? Well, if you divide each of those by 2, you'll get 1 to 4, right? It's like equivalent fractions. So 1/4 equals 2/8. Yes, it does. So here's the thing about factoring by grouping. Anytime you have a descending pattern in terms of, you have a pattern in exponents that, actually there's so many different patterns you could have in exponents. I maybe won't go into that, but it's the pattern. It's really the focus is on the first two terms and the second two terms. This is always, by the way, you're going to factor like this when there are 4 terms. Okay, so let's now look though and see specifically what happens with another example here. So will we end up with the exact same thing? Okay, so let's try this. So if I look here, I've got, oh, darn it, sorry. There we go. Okay, so let's take a look at this. So I'm factoring 3x squared negative 13x plus 12. So remember that in this case, a non-monic trinomial, or non-monic means not 1. So or a complex trinomial, so this number after you've common factored is different from 1. So what I need to do is multiply the a value with the c value. That's 36, okay? So then the two numbers have to multiply to 36, and they have to add to the b term, which is negative 13. So I did that. I think you can do that. It's going to be negative 9x and negative 4x. And now we have 4 terms. Okay, so this negative 13x breaks down into negative 9x and negative 4x. Okay, so now I need to factor that. So what would it be? And I get the two numbers. Yeah, the two numbers are negative 9 and negative 4. Again, common factor the row, first row, 3x. Common factor the bottom row, negative 4 and 12 is negative 4. And the reason we take out a negative because it's a leading term. Then I divide. 3x squared divided by 3x is just x. Negative 9x divided by 3 is negative 3. So then we know that the factored form of this is 3x minus 4 and x minus 3. Okay, that's the factored form of this. Now let's go back to this idea of ratios. So if I had these 4 terms and you wanted to know if those four terms could be factored by grouping. What would you do? 3 to negative 9, negative 4 to 12. So are those equivalent ratios? Well, let's write it as a fraction and see if it is. So what I would end up getting is, and it's a lot better actually, isn't it, if we divide the top by the bottom. So I'd go negative 9, sorry, the bigger number by the smaller number. Negative 9 divided by 3, is that equal to 12 divided by negative 4? Well, for sure it is. Negative 3 equals negative 3. Okay, so if the ratios are the same, so 3 to negative 9 is the exact same thing as negative 4 to 12, that means I can use factoring by grouping. We're going to do another example here. Okay. Remember, we're always going to common factor first, okay? We're always going to common factor first. So this time we're going to factor CFF. That's what CFF means, common factor first. Negative 20x to the fourth plus 50x cubed plus 60x squared minus 150x equals 0. 1, 2, 3, 4 terms. So with 4 terms, the only really efficient way to factor is by this method of grouping. Okay, so what do I do first though? I have to common factor. Negative 20, 50, 60, and negative 150. Well, I'm pretty sure I can common factor out negative 10x. So I factor out negative 10x and then divide each term by negative 10x, and I get this right here. 2x cubed minus 5x squared minus 6x plus 15. So the first thing I have to do is check my ratios. Okay, I have to check the ratios. So I go through this. Oh, by the way, I'm going to get an x-intercept of x equals 0 for that negative 10x, because negative 10x is going to be 0. Now, when I do this, I'm going to check my ratios. 2 to negative 5. Well, there's 2, negative 5, and then negative 6 to positive 15. Are those equal? Well, let's actually maybe come over to here and see if they are. I'll come right over to here. So are these equal? Well, let's see. Well, I would have the first ratio is 2 to negative 5. So I'm going to write negative 5 over 2. And then the other ratio would be, does that equal 15, right, divided by negative 6? And if you look, that's negative 2.5. 15 divided by negative 6 is negative 2.5. Oh, so they are equivalent ratios. Okay, so the first two terms, the second two terms will have the same ratio. And that means I can use factoring by grouping. So the process is actually quite simple now. I take those 4 terms and I put them in order. So the first 2 terms will go in the first row. The second 2 terms will go in the second row in the box. There we go. Okay, so I can go through now, and I can common factor going across. 2 and negative 5, there's no common factor there, but x squared is common. And then across the bottom, 6, negative 6 and 15, well, that's negative 3. And then I divide. 2x cubed divided by x squared is 2x, and negative 5x squared, negative 5x squared divided by x squared is negative 5. So now what I've got is the outside is going to be x squared minus 3 times by 2x minus 5 equals 0. Okay, and we've factored by grouping. Okay, and then to solve this, I would end up with x equals plus and minus root 3 comma x equals 5 over 2, 5 divided by 2. Okay, so x squared minus 3 equals 0, so add 3 and square root. Okay, but again, the key is recognizing what you can do by grouping and what you can't, and that's always done if you have you can do that if you have those ratios the same with 4 terms. Okay, here's another one. Okay, we're going to do one more. And we're going to do this just a few at a time. So, and the way we're going to do this is just check the ratios. Okay, I'm just going to check the ratios. So each time. So look at the first one. X to the 6th minus 5x to the 5th minus 3x to the 4th plus 15. Oh, whoa, whoa, whoa. So this one here, it looks as though the ratios are correct, but there has to be some pattern in the exponents too, right? So look at this. 6, 5, 4. This would have to be x cubed. Okay, since there's no x cubed there, we cannot factor it. Ratio doesn't even matter. I can't factor it because there's no pattern in the exponents. The exponents must also have a pattern. So we cannot use factoring by grouping on this one. Let's check the next one. X cubed minus 4x squared minus 10x minus 40. What's the ratio here? Well, right there and there is 1 to negative 4. And let's zoom on this a bit. It's a little easier to see. 1 to negative 4, does that equal negative 10 to negative 40? Well, this one looks like it's correct, but look at this. Positive 1 to negative 4, those are both negative. If just one of them was negative, we'd be fine, but it's not. So again, we can do this by dividing the larger one by the smaller one. So I could go negative 4 over 1. Does that equal negative 40 over negative 10? That's a negative, that's a positive. So this one we still cannot factor by grouping. Okay, let's check the next one going down. Okay, we're going to go down to that one there and check our ratio. So first thing I need to look for is, well, I would common factor always first, right? But then I need to look and see if there's a pattern in the exponents. So I would do 8, 6, 4, 2. So that's a linear pattern. And I guess that's what you need for the exponents. Now that I think about it, you have to have some form of linear pattern. If you have a linear pattern, you will be able to factor by grouping. So let's check our ratios now. So the ratio here, that's a 1, that's a 4. So 1 to 4. And does that equal 5 to 21? Well, divide the larger by the smaller. So 4 divided by 1, does that equal 21 over 5? Well, that's going to give us a decimal, right? 5 doesn't go into 21 without a remainder. So the ratios are not the same. So this one cannot be factored by grouping. Okay, we've had a lot that we can't factor by grouping. Then let's go to this last one down below. Okay, so let's see here. Now this one here, I'll probably have to zoom on it a little bit more there. And yeah, it's a little bit harder to see, isn't it? The red one at the bottom there. Okay, there we go. So now let's go ahead and figure out if the ratio is correct. So again, I'd common factor if I had to, but I've got 4, negative 14, negative 6, and 21. Well, let's see if those are equivalent ratios. So 4 dot dot for the ratio to negative 14. And does that equal negative 6 to 21? Okay, I'm going to check and see, is that true? So the coefficients, 4, negative 14, negative 6, and positive 21. So what I need to do is, again, check and see if that's the same ratio. Again, you can divide the larger one by the smaller one, and then just get simplified fractions. That would be negative 14 divided by 4. Does that equal 21 divided by negative 6? And if you check, again, if you reduced it to lowest terms, you'd have negative 7 over 2. For that one there, you divide the top and bottom by 3, and that would also be negative 7 over 2, or 7 over negative 2. So this one, yes, you can use factoring by grouping. So then, in terms of what would you do after this point, let's go back over to here. Oh, wow. Let's go back over to here and see what we would do. Well, we would set up a new grid, right? You would definitely set up a new grid, and your grid would end up looking like something like this, right? And all you need to do is put those numbers in the grid. So 4x squared, negative 14x, and then the next row would be negative 6x and 21. And again, you factor across the rows and divide down the columns, okay? All you need to do, the big thing to do is check the ratios of the coefficients within the constant there, okay? And check that there's a linear pattern in exponents. 4, 3, this would not have worked. This should have been a 2, and this should have been x, okay, if I wanted to do this correctly. So sorry about that. And we're going to assume that it had those exponents. So a pattern for 3, 2, 1, and then the coefficients, the ratio of the coefficients in the first two terms and the second two terms are the same. Okay, folks, so good luck with your practice.